skill required to solve a permutation combination question is very different from the skill required to solve a time speed distance question. But in DI that doesn't happen. In DI all question types ultimately merge into the same things. Hi everybody, welcome back to the Arun Sharma Mindworks channel. You're with me Arun Sharma. In today's video we're going to have a look at data interpretation, the preparation of data interpretation, a key strategy or key points that you need to understand for DI prep. DI, of course, is one of the most important areas of your CAT prep journey. Reason being that it's a critical part. More than half of the DILR section is built on data interpretation every time, which means that in a 2-hour exam with 40 minutes on the DILR section, you'll be spending around 20 minutes in the exam only solving DI. On a 3-hour exam with a 1-hour section on DILR, you'll be spending around 30-40 minutes sometimes only solving DI. So you better get your DI skills up and don't neglect it. One of the first mistakes people make when they prepare for DI. The next thing that you need to understand about DI prep is that data interpretation does not have any portion. One of the biggest mistakes people make when they're preparing for DI is to try to segregate data interpretation into portion like pie charts, bar charts, line graphs, XY charts, spider graphs, triangular graphs, etc., caselets. Now you need to remember that while these are different kinds of representations of data, they are not chapters in the sense that you only need to segregate your DI prep on these lines for maybe the first 15 to 30 days of your preparation till the time you are comfortable reading these charts. Why they are not conventional chapters is because when you are solving a pie chart question, a question based on pie charts, versus when you are solving a question based on bar charts, you will see that you are more or less doing the same kind of stuff. So it's not like in maths, permutation combination is a different chapter from time speed distance, because the skill required to solve a permutation combination question is very different from the skill required to solve a time speed distance question. But in DI that doesn't happen. In DI all question types ultimately merge into the same things. So trying to segregate your DI on the basis of pie charts and bar charts is perhaps, I feel, the wrong way to look at it. You can spend 15 days to 30 days, your start of your preparation, on these data representations. Which is why I've put them in my book at the start, so that you are comfortable with what each of these charts is and how you read that. But I don't think it's more than 15 to 30 days of your preparation that you should be headlining your preparation on the basis of this. So for a portion or for a subject that has no portion, no chapters, the preparation of DI and learning through DI is completely through problem solving experiences. While there is no portion in data interpretation, you should understand and you should realize that skill differentials are very high in DI. So you might be able to solve a question in 5 minutes, I will solve the same question in 2 minutes, or vice versa. You might be able to solve a question in 8 minutes, I might take 15 minutes to solve it, and somebody else might not be able to solve it. So skill differentials are definitely there. And if you cannot headline your preparation on portion, how do you study the subject is a question that a lot of people ask me. And a question that is at the foremost, at the topmost of students' preparation question marks. And what do I do in data interpretation? So to answer that question, as I said, the key is problem solving experiences. And you will go through two kinds of problem solving experiences when you are doing DI. One kind of problem solving experience is assisted problem solving experience, where you have assistance of a teacher or a book which is telling you how to think in that situation. The second part of your problem solving experiences, and the more critical part of your problem solving experiences, is what I call as self problem solving experiences. And the general thumb rule is that I tell people is that if you go through around 50 to 75 sets to assisted problem solving, you should be able to start to grasp what DI is all about, and the kind of stuff you need to do in data interpretation questions, and you should be ready to move to your self problem solving experiences. So my advice is not that you do 50 to 75 assisted problem solving to start with and then move to self problem solving, but what you can do is you can do maybe 10 to 15 assisted problem solving sets to start with, and then you can slowly start picking up sets on your own, and accept the fact that there will be some percentage of questions you will not be able to solve on the first go, and you just need to get more skilled and come back to them later. But just keep going through your self problem solving experiences, and Every question that you solve on your own will teach you a lot, and it will also give you a lot of belief in your ability to solve DI. So when you are trying to divide your preparation into problem solving experiences, DI nowadays can be clearly split based on what is asked inside a question. You can clearly split your data interpretation into two kinds of questions: traditional data interpretation and logical data interpretation. Now let's have a look at each of these. What are these two? Traditional data interpretation is the data interpretation which requires you to mostly be able to read data, understand the language of the question, which is asking you for some information to be extracted from the data. And the third step is, based on the understanding of the language, you should be able to create an equation or a formula and extract the numbers from the given charts or graphs or tables and put it into that formula and then calculate. So traditional DI is about data reading, data understanding, data reading, language of the question understanding, information analysis, what information is being asked, understanding that, creating a formula, and then extracting the data from the given table or charts or bars, reading that and extracting it and putting it there and calculating. That's what traditional DI is. Logical DI, on the other hand, is completely about, not just about data. It's of course it also involves data understanding and data reading, and also understands language, also has a language understanding component in it, and of course there's also data extraction in it. But apart from all that, in logical DI, it's not just data extraction. It's not like you read a question, you form a formula and you extract the data and you calculate. It doesn't work that way. In a logical DI question, you have to take your given data through a series of steps, through a series of transitions or transformations, which can be called as a series of analysis, which you have to do before you can get to a point where you are able to read the answers of the data. And unless you can deduce those analyses, and most of these analyses are based on logical understanding of the situation, and at the start you'll start feeling that every situation is new when you do a logical DI, but gradually you start realizing that they too, like most things in DI, become repetitive. And that's my last point in this video, and that is that when you start doing data interpretation, and when you continue doing data interpretation, the first 10, 15, 20 steps, you will see everything new. You will not be able to understand what's happening. You'll not be able to get a grip of that subject. But my request to you is to soldier on at that point. And you will start seeing that data interpretation completely becomes repetitive in nature. So there are 6-7 things in DI that repeat itself. Data representations repeat. As I tell people, there's only one time in your life that you'll see a layered pie chart for the first time, right? Just say, how many times did you see a person for the first time ever? How many times did you see Amitabh Bachchan for the first time? Only once. So similarly, every data representation, it might be unique to you for the first time, but it will only be once. Second time, it's something you've already seen. So data representations repeat, data structures repeat. If I tell you that profit right, so cost plus profit is revenue, that's a data structure. A plus B is C. And the same data structure can be used in number of boys per number of girls in a class is equal to the total strength of the class. The two data structures are exactly same, A plus B is C. And you will start seeing that because DI is completely on linear equations, you'll realize that data structures will only be using A plus B, A minus B, A into B, A divided by B, and that's why there's a limited set of data structures that operate in DI, right? So if there's only two variables, it can only be 4 or maybe 6, A plus B, A into B, A minus B, B minus A divided by B, and B divided by A. There are only 6 data structures which exist in data interpretation between two variables. When there's a third variable, of course, the number goes higher. You can have an A plus B into C or A plus B divided by C. There can be many variations to it, but broadly you should realize that data structures will start getting limited, and there will be only a one time that you'll see a data structure. If you're a little bit perceptive about data structures, you start realizing that they too start repeating. The third thing that repeats is language in the question. So language in DI is full of ratio language, average language, arithmetic language, so to say, language also from number systems at times. So you have to, again, you will see one kind of language only once, and these languages will come from mostly from the arithmetic part of your quants, and that's one of the reasons why people say that you should do your data interpretation after you do your quants, arithmetic part of your quants. You should start your DI after you do at least 4-5 chapters of arithmetic and quants. So you will see that question language repeats. Then the analysis steps for analysis will repeat. You will see that the same kind of analysis happens all the time, right? If there is a missing data question, one missing data question is very similar to the next, is very similar to the third, is very similar to the fourth. If there's a cross-reference data question, you will see a cross-referencing. By cross-reference I mean, suppose there's a school which has boys and girls, and it has got sportsmen and scholars. So if there are 500 students in the school, you will see that there are 4 kinds of people. One division is boys, girls. The other cross-referencing of this is sportsmen and scholars. So boys who are sportsmen, boys who are scholars, girls who are sportsmen, girls who are scholars. So 500 people get divided into these 4 kinds of students. So that's what cross-referencing data is. So missing data is a very key element. So the data analysis steps will keep repeating. Missing data is a key element that repeats all the time. Cross-referencing of data is something that repeats all the time. Multiple possibility situations repeat all the time. A lot of times you'll see in analysis situations of DI that they introduce 3 variables A, B, C, and they give you only 2 equations to handle it, which means that they are leaving you with a multiple possibility situation. So this is something which is very, very common in data interpretation, this thing. And you'll start seeing that all these analysis structures repeat over a period of time. So when you're doing your first 30-40 sets, you'll encounter most things for the first time. But after that, you'll start seeing that even the data analysis becomes repetitive in nature. And then of course, the 5th thing that repeats is the calculations. The kind of calculations in DI are limited to addition, subtraction, multiplication, division, percentage calculations, and ratio comparisons. There are only 6 calculations that form the crux of DI, and you will only be doing any of these calculations for the first time only once. So if you come across a ratio comparison situation, you have to try to think about, the approach in DI has to be, you have to try to think about, okay, I saw this ratio comparison situation in this question. Now I have to become, or I have to develop the steps, or I have to develop the process that I can do this kind of ratio comparison, or even a slightly tougher ratio comparison situation faster than anybody else and more accurately than anybody else. Because DI is mostly repetitive in nature, after the first 100 sets, after the first 200 sets of solving, you'll start yourself realizing this part. And because it's mostly repetitive in nature, the process of DI is always preparation, is always that once you encounter a situation for the first time, you get ready so that the second time you can handle it much more intelligently, much more efficiently, and much more accurately. And if you keep improving efficiency, your intelligence and your accuracy on those situations, you'll suddenly start realizing that you are right up there with the best. So that is my advice for DI preparation. I hope this helps you. I'll take leave now and I'll be back. Do comment on the videos, do like the videos, do share the videos, do subscribe to the channel if you have not already done that, and do press the bell icon so that you know what we are doing fresh. And do let me know in the comments. I read all the comments that come on the channel, even if I don't reply to all of them, but I do read all the comments. So do write in the comments what more you want from us in this channel. Thank you so much. Bye.